our studio screen. Please let me know if you can see my R Studio screen. Okay, great. Okay, so today we will not talk about much. Today we're gonna talk just one more thing. Last time we talked about the if else command, right? We talk about if and else command, maybe class practice example, and then we reached okay. So last time we talked about the if and else command. So I hope this thing is clear to everyone. Please let me know if you have any question regarding the if else command, because we're gonna talk about if else command more in detail now, and combining this if else command, if else loop with another loop. It's clear? Is it clear to everyone? Okay, so let's talk about the for loop today. What is for loop? We talked if loop, if else loop, and now we're going to talk about for loop. What is for loop? In for loop, what it will do, it will do the same thing. It will do the same thing repetitively. Okay. So for example, you have an equation and you want that if you change the value of x, what will be the value of y? Okay. So for now, let's take an example of our today equation. Let's say you have y is equals to, like, this is equation. You can say that x squared is squared, x squared plus 2x plus 3. Let's say you have this equation, and in here you will define x is equals to 3. Sorry, we have to multiply sign. Okay, x squared plus 2x plus 3, you have this one, and x is equal to 3. Okay, so let's say x is equal to 3 and y is equal to this one. It will give you x is equals to 3, y is equals to 18. So what if I want from x is equals to 1 to 100, what will be the value? I want this one, right? So let's say, we will do for loop this one. Okay, so I would say for, I will write for variable. So in here we have to apply for variable. For example, variable, we say I into 1 to, let's say, 10. Okay, let's say 1 to 10. Okay, so print okay. So we can say that not x, let's say x. For x in 1 to 10, print this value. Okay, let's say what it's gonna show. Now you can see here, it's tell me the value of 6, 11. So it means when value is 1, it is 6. When value is the value is 2, its value is 11. When value is 3, its value is 18. So I put this loop. So one more thing. Sometimes it is like, you can say that tricky or something. You cannot save it. Like, it will pop up somewhere here, but you cannot have any value somewhere here. So for this one, what you're gonna do, you will make two arrays. What you're gonna say that x is equals to 1 to 10, right? and you will say that for x is 1 to length 1 to length of x. Length of x mean, let's say, what is the length of x? Length of x. Length of x mean, sorry, I didn't run this one. Okay, now it means there are 10 values. Okay, so you can have any other value, like x is equal to sequence, like you can say that first value 1, second value 19, like say 19, and length out dot out is equals to, like you have 15 values in here, right? Let's say this is your x value. You have these different values in your x. So you want to say that find the value of y for each corresponding value of x, right? Now, what we have to do, we have to make an imaginary empty array that will store the values corresponding to x into y. So what we're gonna do, we will make array, and it will ask you what data you need. I need a data equals to NA. Let's say I don't know the data, so I will just say NA. I don't have data yet. And it will ask you dimensions. What should be the dimensions? What should be the dimensions? So can anyone tell me what will be the dimensions of y? Can anyone please tell me? If x is equals to have the length of 10, what will be the value, the dimensions of y? Can anyone please tell me? Any one of you, please. Yeah, great, Jaren. You are very responsive all the time, but other students, I don't know why they are sleeping or whatever. Okay, so as Jaren, he told us that in the y there will be the same values, because for each value of x we will have a one value of y. So x is 10, then y will also be 10. So there are different things. For example, I can say that dimensions should be equals to 10. Dimension should be equals to 10. It's fine for me. I don't care. Or for example, in here, length of x is equals to, I think we put the x is 15, so it should be 15 as well. If it is 10, then it will be 10 as well. Okay. Okay, so I would say that my x is equals to this one, and corresponding to x, it will give me y. So right now, I don't have any y values, right? Unless I make a loop. So what I'm gonna do, I will say for x in 1 to length of x, print, or you can say that y is equals to this one. Okay, now you will introduce any imaginary variable. You will say for I in 1 to length of x, x of I, it means if the value of, now it is the dimension. If it is first element, let's say x of I, what is x of I? It will not give you because we did not define. Let's say I is equals to 1. Okay, so x of I, mean this one. For example, if say x is equal to 2, it is this one. X is equal to 3, this one. So corresponding to each x value, so we have to add I in here. Sorry. And then x I, sorry, and then, okay, sorry, this one should be 2x. 2 multiplied by, okay, plus 3. Okay, so please try to understand what it's gonna do for I in 1 to length of x. So 1 to length of x mean 1 to 15. Let's say 1 to 15. yi. Now I values will change 1 to this value. Okay, when I is equals to 1, its value will be 1. When I will value is 2, its value is this one. So you can say that sorry, x, sorry, when I is 1, then this value I is equals to 2, I is equals to 3, I is equals to 4, I is equal to 5. So now I will run this one. So I run this one, and now I will see my y. Now my y is this one. So now if I want to join, I will say x or z is equals to a. I told you about the binding of the columns. So we can say that a bind, row bind, r bind, or call bind, co bind, bind, c bind, I guess. Yeah, c bind x comma y. Let's say, and let's see the z. Now you can say that corresponding to x, there is y, x and y, x and y. So we have these values. Okay. So for example, now I want to change, let's say I want to change the more values, like I don't like 1 to 19. I want like minus 30 to 19, like somewhere this one, and let's see, its value will be different. So its value is here, different. So there is another thing you should learn is okay. So it is always a good idea to plot a graph. So plot, if you want to plot a graph, just say plot, and then z dollar, oh sorry, what is the x-axis? X comma y, and type is equals to L. You want a line, and that's it. Okay, so this is the graph. You make it. Okay, so earlier you guys, I remember we were studying about the graph. Which graph we talk about? This one, right? We talk about this one. Let's make this one. Copy. So our is x log 10 of, we can say that copy. Okay, y is equals to I is equals to xi square, sorry, x log 10, there should be a multiple sign, multiply sign, log, sorry, log 10 of x and plus 3, right? Plus, oh sorry, minus 1.2. and then it should be I. Okay, now I want that I also want to find two different functions. Y is equal to this one. I would say, okay, it make it like z, or like the x, y, z. Let's say it's u. Okay, and then I'm gonna do the same thing because I'm gonna store it. I will say u. Okay, so now I will have, it is minus, okay, x log of x minus 2. Okay, so let's run this code now. Hmm? There are any values because maybe the solution was not real. So let's try to like change the values in x, like 1 to 20, let's say. Okay, so now we'll u and u as well, and then let's see the z. Now you see in x corresponding to y, what is the value, and corresponding there will be a value of u as well, right? So now if you want to make a graph again, you want to make a graph, so you will say x and then just put the u and then make a graph. So this is let's see, in first thing what we gonna, I say that 1 2 3 4 and x log x into minus 1.2. So it should touch this one at value our, okay, I'm more interested, okay, in here it should touch this line. Okay, so let's try to make it more, we can say that x is equals to, we started from 0 and, sorry, let me see again, we started it from 1 and 4. The solution lies between 1 to 4, right? What was the solution? Our solution was like 2.73, right? Somewhere here. So let's just make this interval instead of this one. So 0 to 4. Okay, let's run this one. Okay, and then this one, and then, okay. So in here, you can see that somewhere here, this is 0. Okay, this, oh, sorry, this one is 0, I guess. Yeah, in here, your solution will lie somewhere here, right? It was 2 point something. The x value was kind of something. Okay, so where is this one? Okay, in here. So 2.7342. Okay, yeah. It will. Okay. So there is another thing. You can add the lines, I guess. What was the command of? I forgot. X line, AB line, AB line. Yeah. Okay, so there is AB line, and then it will ask you the A value H horizontal, H V H. it should be a horizontal. Let me add the h is equals to 0. And I would say call is equals to maybe red. Okay, let's add is equals to true. Add is equals to true. Let's see, I forgot. Okay. Oh my god, I don't know why it's in Korean. I never use it in Korean. I don't know. I changed. Okay, anyways. Okay, so here you guys can see that y is equals to 0. It touches somewhere here. So this is my solution, right? So for example, if I want to be more brief, like I want to see more in detail, so I will take the interval 2 to 3, right? So let's say I will say my x interval is 2 to 3 somewhere here. Okay, let me write and run the code again. You can see we are more precise. So we can be more precise, like we can say that our this solution lies somewhere 2.8 to 2.6. We can just 2.8 to 2.6, right? So let's run the code again and make a graph. See here, we are getting closer and closer. So this particular point corresponding to x value is your solution. Okay. Is it clear? I think add is equals to true is you don't need to plot this one. Okay. A warning message. I don't know what this is warning message. Okay, so we can be more precise that our solution again, it was 2.73. Okay, let's try to copy this one and make the interval somewhere here. So I will put the x value, like the first value here, second value here. Okay. And let's run the code again. Okay, so here we have this intersection point. Is it clear to everyone? Is it clear to everyone? Please let me know if you have any doubt. Okay, so one more thing, you can also add a vertical line. For example, if you want to add a vertical line in your graph, what you're gonna, so instead of h is equal to 0, you put v is equal to 0. And you want to change the color, just change the color to green. Okay, let's say, okay, so green, v is equal to 0. So along x-axis, there is no v is equal to 0. So if I want to add a vertical line, what I'm gonna do, I'm gonna add a line at the vertical 2.7. It should be here. V is equals to, okay, again, maybe vertical 2.7. No, we need to add a AB. I don't know. AB line. It should lies 2.70. Okay. It is out of the range. Let's say 40. Okay, so now there will be a line. We can say that we can say that plot a line between not 2.7, just maybe I don't know how. Okay, so there is another interesting thing. You can also draw like the plot several times. For example, you will say for uh, what you can say that uh, uh, x, or you can say that in x in like 1 to 10, or you can say that for example you want to try the different lines in this one, so you will or create a sequence like we can say that we can say that x line is equal to sequence from, let's say, from 2.74 from 2.74 to 2.740 to 2.742, and sorry, length dot out is equals to, let's say, 20 lines you want to draw. Okay, so this one. So x is so x. Okay, so for x in, or we can say that again, I in 1 to length of x underscore line, AB line, and V is equals to X line into I. Okay, so it will draw your several lines here. I guess it should draw. X line is not found. Excuse me. Okay, sorry. Now you can see, and let me zoom. You can see it draws a lot of lines like after some intervals, and we can see that our solutions lies somewhere here, right, at this particular point. You guys got it? Okay, so there is another interesting thing. What you can do is you can manage the sorry, not here. You can manage the x limit. For example, I want x limit only, x limit is equals to c to x limit should be, my x limit should be only this one. Okay, the first one and the second one. I want this x limit only. Okay, so I have this x limit is changed, and AB line, this value in here, and then I have this one, and then I have drawn different values in here, and then I will zoom it. I don't know, sometimes it happens. Oh, anyways, so this is your solution. This point is solution. So is it clear to everyone? How can we use the for command, for loop in R? If you want to do many things again and again and again, then you will use the for loop. Any question regarding this one? Okay, so I'm gonna send you this one in your chat box, so you guys can try it at home. So everyone, Dominican. Okay, so one quick thing, can you make this function and this function? Let's try to see if our answers are correct. Can you guys make this and these two things? Is it visible, right? It's question number one and question number two. Please try to make this one and just check if your answer is correct, your answer lies within this value or not. So do it quickly, make a graph and send me the graph. So, okay, students, that's it for the today class. So I hope you guys can try this coding at home, and please let me know if you have any issue or problem with this coding. And see you tomorrow, okay, at the same time. And take care. See you. Bye bye.